Hey guys, welcome back to another video. In today's video guys, we are going to be having a look at the chemical reactions, which is the topic 7 of the IGCSE chemistry syllabus. So in this chapter we talk about the chemical reactions, the different types of chemical reactions, the rates of the reactions, how we can increase a certain type of chemical reaction, and the different factors that affect a certain type of chemical reaction. Now, this topic is a very vital area of chemistry, because without chemical reactions, chemistry would just be theoretical. Okay, chemical reactions is such a vital part of chemistry that without these chemical reactions, we cannot form products. Okay, we also then look at rate of a reaction. Okay, what is the rate of a reaction? Rate of a reaction is how fast or slow a chemical reaction undergoes or takes place. Now, there are some chemical reactions that could take even months. Okay, and because of that, we could have many factors affecting that throughout the month. We can have so many factors affecting that chemical reaction that we do not get accurate results, and therefore it's very important to understand the concept of a rate of a reaction. Now, within this rate of a reaction, we look at temperature, we look at pressure, we look at a catalyst. We'll also look at different types of chemical reactions, because in chemistry we have displacement reactions, we have decomposition reactions, right? We have photochemical reactions, which involve the use of light, meaning that reaction can only undergo if there is light. Okay, so this chapter we talk about all of that. We talk about the different graphs and how we can represent a chemical reaction with the help of a graph, whereby if the reaction is very fast, the gradient of the graph is steep. So basically that is just the introduction to this topic. Okay, and we're going to be going over the entire topics of this entire syllabus. We'll look at redox reactions, reversible reactions, all sorts of stuff like that. Okay, so this is the video 7 of the ongoing series. I didn't upload in quite some time, but I will try my best to upload as the upcoming October-November series, or upcoming October-November exams is coming close. So let's further ado, let's begin and talk about the rate of a reaction. What is the rate of a reaction? Okay, when you say a rate of a reaction, the first thing that comes to your mind is the word rate. Okay, this word rate. Okay, sorry, let me erase this actually. So the rate of a reaction. Okay, this word rate, what does this word rate mean? Okay, rate is simply the speed of this chemical reaction. The rate is the time that is taken, okay, for you to actually execute a chemical reaction. Okay, so so we're going to highlight all these words as we go through. I'm going to be reading through the sentences and explaining as we go on. Okay, the rate is a measure of how fast a chemical reaction goes and its speed. Okay, how fast the chemical reaction goes and its speed. The rate of a chemical reaction is the speed, okay, again speed here, at which the reactants are used up or when the new products are formed. So a simple chemical reaction is comprised of reactants and products. Okay, reactants would be, of course, on the left side, and then products on the right side. So we show this through the help of an arrow. An arrow in chemistry represents a chemical reaction, whereby here would be the reactants and here would be the products. So the rate of reaction is how fast this, right, reacts together or uses up, and how fast the product is formed. Okay, that is what it means by the rate of a reaction. Okay, the speed of the reaction. Okay, so in simple words, we're looking at how fast these reactants are used up and how fast these products are formed. Okay, that is a simple definition of a rate of reaction. Now, as we go on, this will be really important. Right now, you might think, okay, rate of a reaction, that is, of course, general knowledge. Rate of reaction just simply means the speed. Rate of the reaction simply means how slow a reaction is, because we all know what rate means. So therefore, rate of reaction is simply the time taken for a reaction to take place. But why am I emphasizing so much on rate of reaction? This is because The IGCSE tests you on several aspects that involve just the rate of the reaction. Like for example, you'll see so many questions in the IGCSE that talk about the graph. Okay, now the only way you would understand the graph is with the help of understanding the rate of a reaction, because if we have, for example, the start, the graph is steep, that means what happens? The rate of the reaction is fast. When it slows down, when the gradient slows down, what does that mean? The rate of the reaction decreases. Okay, so let's get this through the help of some examples here. Okay, to measure the rate of the reaction, we have several factors. Okay, we have several ways we can do this. Okay, we have several ways we can do this. The first way is through the help of mass. Okay, if the mass changes, okay, you see the products and the reactants have different masses, of course. Okay, so the mass of the products will be different compared to the mass of the reactants, and we can measure the rate of the reaction through the help of a mass. How fast does the mass change between reaction 1 and reaction 2? Example, how fast will the volume change compared to reaction 1 to reaction 2? How fast is there a color change? If there is a color change fast, that means the rate of the reaction is fast. So the vital aspects here is mass, volume, and color. Okay, those are just some examples of how you can measure the rate of the reaction. Now let's understand this through the help of an experiment. Okay, because the best way to understand chemistry is through the implementation of what we're talking about. If we're talking about displacement reaction, we're going to do the displacement reaction. Now, of course, I can't do it physically in the lab, but of course, theoretical is good enough. So let's begin. In an experiment where a gas is produced, this gas would be hydrogen, because they said that this is the reaction between magnesium and HCl. We know that magnesium, which is a metal, plus an acid forms a salt plus hydrogen. Okay, so this would form magnesium chloride plus hydrogen gas. But our main focus here would be this hydrogen gas. Our main focus is the hydrogen gas. We don't care about the other salt, we just care about the hydrogen gas. Now here, if you can see this right here, okay, I do not know why it is lagging a lot, but anyway, you can see here, this is the magnesium ribbon. Okay, the magnesium ribbon is put into this flask. Okay, the magnesium ribbon is put into the flask, and this right here, the liquid here, is HCl. They will react together and will produce hydrogen gas. This hydrogen gas will go up the tube. This hydrogen gas will go up. Okay, what is happening? 1 second, guys. Yeah, so this goes up the tube, it goes all the way, and the gas is collected. Okay, so the gas goes up the tube, and then in the gas jar it collects how much gas it is. Then we use a stopwatch to see how much gas is collected over how much time. Okay, so that is the experiment. I've explained it. It's simply a simple experiment with the help of a metal and an acid, and how fast the gas is produced. Now, how do you display these reactions? How do you display these experiments? Because in chemistry, we need to always represent data. Okay, we always need to represent data in different ways, and the best way would be a graph. Okay, so let's see. The results of this such experiment can be used to plot graphs. The rate of the reaction is the slope. Okay, guys, get this. This is the slope. That means the steeper it is, okay, the steeper it is, the faster the rate of the reaction. Now, if you're writing notes as long with this video, you need to write that down. The steeper the gradient, the faster the rate of the reaction. Okay, because this is going to be very important when we start doing the questions. Because these types of graph questions, they give you a graph and they say, for example, where is this reaction the fastest? Okay, and the reaction is always fastest in the start, in this region here. It's always the fastest. The start is where the gradient is the most steepest. Okay, and then the rate of the reaction will slow down because reactants get used up. The reason to why, you know, the rate of the reaction is very fast in the start, okay, is because we have so much reactants. Okay, so they get all used up, and then in the end, eventually there will be no product, and hence why the reaction will slow down. Okay, now the average rate of a reaction can be calculated with this formula here. And the formula that they have used here is volume change, the volume change over the time taken. Okay, because we used a stopwatch, we've measured the time, we've also measured the volume with the gas syringe. Okay, if the volume was in centimeters cubed, the units would be centimeter cubed per second. Okay, if it was any other unit, it would be per second or whatever. Okay, you could measure a gas in different, if it was dm cubed, it would be dm cubed per second. Okay, equally it could be the change in mass with the time. Okay, if it was not a gas, for example, if it was if we were measuring the mass of a certain substance, we will look at the change in the mass over the time. You know, the change in that mass over the time will give us the average rate of the reaction. So here we have the graph. Let's try to understand the graph. The y-axis, it simply says that this is the amount, this is the amount of product. Let's erase that. This is the amount of product, this is the time, and then, you know, as it goes, steeper gradient, and then it starts slowing down, and then when it's flat, that means the reaction is ended, meaning the amount of products and the time taken are the same. That means that all the product is used up, all the product is now equal. Okay, I'm hoping you're understanding this. Very simple topic, very easy topic. We've just looked at the rate of a reaction and how you just show that with the help of a graph. Now let's look at how we can increase the rate of reaction. Let's see how we can use different factors to increase the rate of the reaction. So let's have a look at that now. Okay, here it is. So changing the rate of a reaction. Okay, that is also very important to understand when talking about this topic. When a chemical reaction occurs, the reacting particles need to meet up with each, collide in order to form new bonds. To form new bonds, simply these particles need to collide with each other, and they need to have enough energy to react when they collide. And this idea is called the collision theory. So what is the collision theory? The collision theory simply says that when particles collide with each other, okay, they need to have enough energy to collide with each other. Once they collide with each other, we can explain the idea of the rate of the reaction. The faster the collisions, the faster the rate of the reaction. The slower the collisions, the slower the rate of the reaction. Now the thing you need to take up, the point you need to take here is that they need to have enough energy, and to supply them energy is what we're going to talk about next. Okay, those are the factors that we need to do. Okay, the factors that we talk about is energy. In terms of energy, how can we increase the energy in this chemical reaction so that we can form new bonds faster, we can make the particles collide faster, and so on and so forth. So let's look at the 4 ways. There are actually 7 ways for the IGCSE chemistry syllabus, but we only need to know the 4 ways that we're going to be talking about in this video. Okay, let's start off. Number 1, the temperature. Okay, if you do physics, you know temperature is such a vital part in almost every reaction. Temperature gives energy. Okay, in simple words, temperature gives energy, more energy, faster rate of reaction. But let's look at it in terms of the chemistry way. Okay, let's have a look at this. Now, increasing the temperature, when we increase the temperature, it increases the rate of the reaction. Very vital part here. You increase the temperature, the rate of the reaction increases. Okay, when the temperature is increased, the particles all move more quickly and will have more energy. The next vital part you need to understand, more energy. Again, you will see in all the factors, more energy, more energy, more energy. And the factors are simply, the factors simply increase the energy. And that is why there are factors that affect the chemical reaction. Okay, thus they will collide more often. Okay, they will collide more often and with more energy. So the rate of the reaction increases, and this can be shown with a graph. Now you need to understand this graph. This graph is very important because in several times the questions they ask is, okay, they will say this is the graph of a reaction. So and so has increased the temperature. What is the new graph? The new graph will have a steeper gradient. It'll have a steeper gradient, but at the end it will be at the same level because the product will have the same amount. If you increase the temperature, the amount of the product will remain the same. It will have the same amount of product, and hence why the lines will intersect. It's faster, so it's steeper gradient. You can see here it's steep. Okay, steep. This is more steep compared to this. Okay, so you need to say that it is more steep, and hence why it's going to be a faster rate of the reaction. Now let's move on to the next factor. The next factor talks about the size of solid particles. The main thing here we're talking about is the surface area. Okay, how surface area affects the chemical reaction. If one of the reactants is a solid, okay, then breaking it up into smaller pieces will increase its surface area. Surface area in simple words is having a big part of area. A solid is this much. If I crush it, it has a big surface area. If it has a big surface area, that means particles will have a higher chance to collide with each other. They have more area to work on for more collisions. And when there is more collisions, what happens? More collisions equals to more faster rate of reaction. The main thing you need to understand here is more collisions. Okay, more collisions is equals to more or a faster rate of the reaction. So here they've given an example of a nail, okay, and only iron atoms on the surface can react. So we have an iron. I've split it into pieces. This increases the rate of increases the surface area because we have more pieces, hence the surface area increases. That means the rate of the reaction of whatever the nail is doing will increase. Okay, here they've given us an example of something. Let's see. In flour mills and coal mills, this can lead to explosions. The air can fill with fine flour dust or coal dust, and with a large total surface area, a spark could cause the dust to ignite and explode. So what they're simply saying is that you have to be really careful, because if the surface area is too much, it can explode. Okay, so you have to also take that into consideration. Let's move on to the next factor. The next factor is about concentration or pressure. Okay, concentration or pressure. So concentration is self-explanatory. If a solution is more concentrated, that means that there are more reactant molecules between the water. That means they have more energy between the molecules, have more energy when they are concentrated. That means the collisions are faster. Okay, the collisions between the reacting molecules are more likely, and in this case, the rate of the reaction will increase. And if you want to talk about a gas, we talk about it in terms of pressure. The higher the pressure, the higher these particles are closer together. That means they will collide more often. If they collide more often, that means the rate of the reaction will increase. Okay, that means the rate of the reaction will increase. Let's move on to the next part. Let's move on to the last factor. And the last factor is what we already know, which is a catalyst. A catalyst increases the rate of a chemical reaction without being used up in the reaction. Now, this first sentence is, you need to cram it till you need to cram this sentence. The entire sentence, you need to just cram it. Exact. And if you leave out the part where you say without being used up, you will get only 1 mark. Usually these contain 2 marks. And if you don't say without being used up in the chemical reaction, you'll get it wrong. So exactly that sentence, I want you to write it down, and I want you to remember exactly how it is written. Okay, now it can work by lowering the activation energy, okay, for the reaction, and thus it increases the number of molecules with enough energy to react. The activation energy is the energy needed to start the reaction. Okay, if you know, I'm always saying activation energy. What is this activation energy? This is the energy needed to start that reaction. Okay, and with the help of the catalyst, it will work by lowering this activation, hence why increasing the number of molecules with enough energy. This energy will be transferred to the molecules, and the molecules will get a lot of energy to collide with each other, and the rate of the reaction will increase. Now, catalysts are very important to the industry as they speed up chemical reactions. Of course, they speed up these chemical reactions. And if we don't have catalysts, reactions would take months, would take years. There could be reactions that could even take years without catalysts. So catalysts were a very, very good invention by humans. Enzymes are proteins made by living cells, and they act as biological catalysts. Okay, they are used as detergents to dissolve stains, and the enzymes in yeast are used in bread making. Enzymes differ from catalysts, so enzymes and catalysts are different. Do not say that enzymes also speed up the chemical reaction, but they are different because catalysts work only in limited ranges of pH and temperature. Catalysts will only work in certain types of temperatures. Hence why later on we'll look at a type of experiment called the Haber process. The Haber process has a catalyst, and this catalyst will only work within a specific temperature, which is 450 degrees, and a specific amount of pressure. Okay, even pH is actually a factor of catalysts. So the difference between enzymes and catalysts, you do not need to know this for the IGCSE syllabus, but it's good for your information. And enzymes and catalysts are different. Catalysts can only work in limited ranges of pH. Now let's study this graph here. Okay, this graph, you need to memorize it. This graph starts off with reactants and has products. The activation energy, if activation energy with a catalyst is low and without a catalyst is high. Usually people think when you add a catalyst, the activation energy becomes higher, but no, it actually lowers the activation energy. The reactants and then the product. Now later on we'll look at it that from reactants to products, if you go down, there's actually a way to draw these types of graphs. When the products are up here, okay, so one might ask, why is the products down? Why is the products down? The products are down because of I don't know if it's in this chapter or not, but we're going to go over these types of graphs. Okay, we're going to learn how to draw these types of graphs. I believe they'll come later on this video. If not, I will come back to this and I will teach you how you draw these types of graphs. But this here is an exothermic reaction, but we'll look at different types of, have we already done this? Yeah, I think we've already done this. In the previous chapter, we talked about this. So yeah, I'm hoping you already understand this. If you watched the last video, you will understand what endothermic reaction is, what exothermic reaction is. So you will understand how to draw the graphs, because I believe I did that in the last video. I did that video a long time ago, so I don't really remember if I discussed this. But if I haven't, comment down below. I'll explain it down if you do not understand. Or check the previous video. I'm sure I think I mentioned this or not. Okay, let's go to the next subtopic. The next subtopic, we look at the effect of light. Okay, the effect of light. Now, light is a very vital and important part of any type of chemical reaction, because some reactions, they get energy from the light, and this type of energies are called photochemical reaction. I want you to remember that any reaction that needs light or the presence of light is called a photochemical reaction. An example to this is photosynthesis. We all know what photosynthesis is. This is a way where carbon dioxide, which is here, CO2, reacts with water, and in this would leave plants using chlorophyll as a catalyst and light from the sun to produce glucose and oxygen. So this carbon dioxide plus water gives us carbohydrates plus oxygen. Okay, try to remember these two equations. CO2 plus H2O equals to C6H12O6 plus O2, where this is the glucose that is formed. Okay, and this is the oxygen. So that is as simple as that. Now, in the 2022 examination, they were asked a question about silver halides. Okay, you need to remember here that silver chloride, silver bromide, and silver iodide decompose in the presence of light forming silver. I want you to remember silver chloride, silver bromide, and silver iodide. Okay, chloride, bromide, and iodide of all silver decompose in the presence of light, forming silver. The half equation for this would be silver plus E gives us silver. This is called an half ionic equation. And yeah, This was used in the photographic film, guys. If you know, in the olden times, how they used to make photos visible was the help of this. It was the help of silver bromide chloride or iodide, where it would decompose in the light, and it would form that picture. So the reaction speeds up as the light intensity increases. So another factor would be light intensity, but in this case you would just need to remember the fact that some reactions look at the presence of light. So you need the presence of light for it to work. Let's talk about reversible reactions. Reversible reactions comes from the name. Simply, reversible reactions means they can go in both directions. Okay, reactants to products, products to reactants, and you use it to represent. You use this symbol, right? Oops. So we use this symbol right here to represent a reaction that is reversible. Okay, so let's move on to more about these reversible reactions. Okay, an example for a reversible reaction is copper sulfate plus water, which gives us copper sulfate hydrated. Okay, and you can reverse this. We know the copper sulfate experiment of water. It's the same idea, where you can reverse them. You can reverse both of this from here to here, here to here. This sign again shows that it is reversible. Reversible reactions can reach a point called equilibrium, and here the rate of the forward reaction is equal to the rate of the reverse reaction. Another aspect that you need to memorize. What happens when there's equilibrium? When there's an equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. The reactions continue, but the concentration of the reactants and products remain. Another thing you need to memorize, concentration of reactants and products remain constant. In many IGCSE questions, they ask you, when there's an equilibrium, what happens? Here you have to say the rate of the forward reaction is equal to the rate of the reverse reaction. And you would say the concentration of the reactants and products remain the same. Okay, that is what you would have to say. If the reaction conditions are changed, this can affect the position of the equilibrium. In a gaseous reaction, the equilibrium can be affected by the change in pressure. Increasing the pressure favors the reaction with the least number of gas molecules. Now, I will explain this in just a moment. We have a reaction, okay? We have a reaction. And the two factors that you need to know that affect a reaction that is in equilibrium is increasing pressure, reducing pressure, increasing temperature, reducing temperature. Now let's explain this. Let us explain this. Equilibrium shifts to the side with fewer gas molecules. What does that mean? What does fewer gas molecules mean? You can see in this reaction, if we look at this reaction, for example, if you look at this reaction, you can see that in this side of the reaction, we have a 1 here and a 3 here. That means it has 4 molecules. Okay, it has 4 molecules. And on the right side, it has 2 molecules. So when I increase the pressure, okay, when I increase the pressure, it will favor the side with fewer molecules. So that means the equilibrium will shift to the right. As you can see with this arrow, it will shift to the right. When I reduce the pressure, it will favor the side with more molecules. Here it has 4 molecules, here it has 2 molecules. Hence why it will shift to the left. Remember, an equilibrium reaction can either shift to the right or shift to the left. But we can make it shift to the right or shift to the left by 2 factors, pressure and temperature. If I increase the pressure of a certain type of reaction, it will favor the side with fewer molecules. So in this case, to the right. And if I reduce the pressure, it will favor the side with more molecules, hence why it will shift to the left. Let's look at the other factor. The other factor is increasing the temperature. If I increase the temperature, it will favor the endothermic reaction. Now, in most cases, the question will say if the forward reaction is endothermic or exothermic. If the forward reaction is endothermic, if I increase temperature, it will shift to the right. If it is exothermic the other way, here it's written exothermic. So if it is exothermic, it will shift to this right. If I increase the pressure, it will favor the side that is endothermic. So in this case, endothermic is from right to left. So if I increase the temperature, it will go from right to left. If I decrease the temperature, it will favor exothermic, which will be left to right. Okay, I'm hoping you're understanding this. Increasing the pressure, increasing the temperature will favor the endothermic reaction. It always favors the endothermic reaction. And in most cases, the question will tell you whether the forward reaction is endothermic or exothermic. Okay? We talked about this in the previous video, whereby sometimes the question will just say that the product is negative this or something like that. Negative. That means it is exothermic. Okay? But you will always improve this through the help of past paper questions, okay? But here you need to understand, if I increase the temperature, it will always favor the endothermic side. There's some other factors like increasing the concentration. It will always favor the forward reaction. If I increase the concentration of the reactants, then it will favor forward reaction. If I increase the concentration of product, it will favor reverse reaction. Okay, so if I favor this side, it will go forward reaction. If I favor this side, it will go this side. Okay, I'm hoping you're understanding this. It's not as complicated as it sounds, right? It's not that complicated. Okay, I'm hoping you understand that now. Let's now talk about the oxidation and reduction questions. Oh yeah, but before that, if we add a catalyst, it does not affect the position of the equilibrium, as catalysts only affect the rate of the reaction. Okay, we talked about this in terms of the rate of the reaction. The only factors that affect equilibrium is pressure, temperature, and concentration. Catalysts do not basically affect the concentration. Okay. Now, let's talk about oxidation and reduction. Let's have a look at oxidation and reduction. Many reactions in chemistry are redox reactions. If a reaction is not a precipitation reaction or neutralization reaction, then the chances are it's a redox reaction. The word redox is short for reduction and oxidation. In simple terms, reduction means the loss of oxygen and oxidation is the gain of oxygen. Okay? In the broader definitions, reduction is the gain of electrons, oxidation is the loss of electrons. This might sound very complicated when you first hear it, okay? What is this? What is that? But it's not as bad as it sounds. I'll explain it in just a moment. When copper 2 oxide is heated with hydrogen, okay, the black copper oxide turns red-brown color of copper, and the following reaction occurs. So this is the reaction that occurs. The copper oxide loses oxygen to become copper. So it is reduced. The hydrogen gains oxygen and is oxidized. So this copper is losing the oxygen, so it becomes copper. And this hydrogen is gaining an oxygen, therefore it is oxidized. When you gain oxygen, okay, so a simple mnemonic to remember is something called oil rig. Okay, where here it is oxidation is loss of electrons. Reduction is gain of electrons. Okay, and here if you lose the oxygen, it is reduction, and for hydrogen it is oxidation. Okay, for a simple reaction. Let's look at another example. Magnesium is getting oxidized, that is oxidation. Okay, the magnesium is burned in the air and reacts with oxygen to form magnesium oxide. So this magnesium is being oxidized, okay, as it gains oxygen. However, magnesium has also lost electrons to form magnesium ions. Because remember, magnesium has 2+ ions, so it is losing ions, and the oxygen has gained these electrons. So oxidation can be defined as the loss of electrons. Okay, that's another way to look at oxidation and reduction. And the famous oil rig can be used to help you with this. Okay, oxidation, loss of electrons. Okay, gain of electrons is a reduction. Here it's a gain of electrons. Here it's a loss. Okay, oxidation and reduction always occur together. Remember that oxidation and reduction always happen together. Okay, and there are always two half equations, one showing. Now let's talk about oxidation states. This tells you how many electrons each atom of an element has lost, gained, or shared in forming a compound. The rules for oxidation states are: all atoms in compounds have an oxidation state. Atoms in elements have an oxidation state of 0. So if it's an atom in an element, it has an oxidation state of 0. The oxidation states of each atom in the formula for compound must add up to 0. Most elements have the same oxidation state as their compounds. Group 1, for example, a group 1 metal has an oxidation state of +1 because it loses 1 electron, hence why the ion will be +1. Right now we're just looking at different oxidation states, if that's what you want if you want to know. If it's group 7, it has an oxidation state of -1. Okay, and then this -1 becomes what is how we decide whether it is oxidation or it is reduction. Okay, now transition metals have something called the variable oxidation states. It is when we talk about metals, we discussed that transition metals have variable oxidation states. Okay, so these just talk about the different oxidation states, changes during the chemical reactions, and then we have something called the oxidizing and reducing agents. Okay, self-explanatory. A reducing agent reduces, okay, but itself it is oxidized. A reducing agent will be oxidized. Okay, a reducing agent is oxidized, but it brings about a reduction. An oxidizing agent will be reduced, but it brings out an oxidation. Okay, what that means is if I'm a reducing agent, I will be oxidized, but I'm called a reducing agent. Does that make sense? If I'm an oxidizing agent, I am reduced myself, but I caused the oxidation to happen. Therefore, I'm called the oxidizing agent. So whenever they tell you to identify the oxidizing agent, you look at the compound that is being reduced. Most likely that would be the oxidizing agent. Okay, so that is that. Let's move on to the last slide, I believe. Now, let's have a look at the test for oxidizing agents and reducing agents. When some substances are oxidized and reduced, there is a color change. So these are useful for tests. Potassium manganate, okay, this is a powerful oxidizing agent. You can just remember this. You can see this becomes to this. So this is oxidation. Purple color to colorless. This colorless, because it's changing color, it shows that it's being oxidized. Potassium iodide, colorless to brown, another oxidation reaction. So yeah, that marks the end of today's video. I'm hoping you understood everything. I'm hoping you understood the different types of rates of the reaction, the factors that affect the rate of the reaction, what oxidation is, what reduction is, how you can identify what an oxidizing agent is, what a reduction agent is. And if you have any questions, feel free to comment down below. Again, I always say that I will try to upload more videos, but I'll try my best because I cover so many subjects in this channel. It's a bit hard to just focus on just one particular subject, but I'll try to upload as many videos as I can. This is topic 7, this is chapter 7, this is video 7, and I am hoping to see you in the next video. So thank you guys for watching, and I'll see you in the next video.